Hi guys, the focus of this video is going to be going through, this is the second page of the packet I handed out today in class. So it's at the top, it should say notes and practice, angles and angle measure. This is again the back of the first sheet we were doing, the second page of the packet. So the big idea here is that we're going to be kind of introducing the idea of radians, which are another unit as opposed to degrees to measure an angle, okay? So today in class, we were looking at angles around the coordinate plane. So I'm going to actually draw a little picture over here. And what we were thinking about in class was we know that if we're always coming up from the positive x-axis, then 90 degrees was here, 180 degrees was there, 270, and then 360, okay? So we still have all of these angle measures, but now we're going to introduce a new unit. And the key is that radians are still measuring the degree of the angle, or still measuring the size of the angle, but no longer in degrees. And the key piece of information is that 2 pi radians is equal to 360 degrees. So if I label that on here, that means all the way around the circle is 2 pi. Well, what is 180? That's only going halfway around the circle, so that would be half of 2 pi, which is just 1 pi, right? So we know 180 degrees is 1 pi. And then if you think about the 90, well, that's halfway in between the 0 and pi, so that would be pi over 2, or half of this pi right here. And then what's going on down here? Well, we can think of it as actually being like 3/4 of the way around the circle. Or you can think of it as being kind of halfway between pi and 2 pi. But either way, you get this like 3 pi over 4. Okay? So those are just kind of like the basic general angles in radians. But we're also going to get a formula that will allow us to convert from degrees into radians or the other way around. And we have these two formulas over here, which is basically, you might have done this when you're changing units in physics class or another class, where we put the equivalent values in the two different units on top and bottom. So like we either have 180 over pi radians because 180 is equal to pi, or you could have pi radians over 180 degrees. Same idea, it just depends on which way you want to convert. So if we look at a quick example, number 1 down here, it says 140 degrees. So I'd like to convert that into radians. And the way I remember like which one to put on top is you always want to put the unit you want to get to on top. So I know I want to get to radians, so I'm going to do pi radians divided by 180 degrees. Okay, and the idea is that your units on top and bottom here will cancel and you'll be left with the units on top. So what happens when we do this multiplication? Well, you can think of it as like 140 over 1. So when we do this multiplication, we get 140 pi over 180. Notice I kind of dropped off the word radian and the degree because, I mean, basically if you have a pi in your answer, we're going to assume that it's in radians. If you see the degree symbol, then we can assume it's in degrees. But now once I've done this multiplication straight across, I'm thinking, okay, can I simplify the numbers here at all? So 140 and 180, I'm thinking definitely I can simplify this, right? So I think they're both divisible by 20 because 14 is divisible by 2. So that would be 7 on top, 7 pi divided by, I know 180 divided by 20 would be 9. So I have 7 pi over 9. Okay, let's just try one more going from degrees to radians. So again, this is a negative 75 degrees, so I would do pi over 180. I'm kind of abbreviating now, but we know whenever we have the pi, those are in radians. So multiplying straight across, I get negative 75 pi over 180. So it's no longer in degrees now, actually, because the degrees kind of cancel top and bottom. And then we want to just, again, try to simplify that fraction. So you could use a calculator, or you could just look at them and say, you know they're both divisible by 5, so you could divide out of 5. If you do that, you get negative 15 pi over 36. And then I see I could still simplify that more because 3 goes into 15 and 36. So then I would end with negative 5 pi over 12. And that would be my final answer. Okay, so let's now look at an example where we're going from radians into degrees. So let's look at number 3 here. So in this one, I would put the degrees on top because that's what I'm trying to get in the end, divided by pi radians. So multiplying straight across here, we're going to get 3 times 180, which is 540 pi over 5. And then I could divide 540 by 5. Oh, and there's also a pi on the bottom, right? So notice something nice is going to happen here because first of all, we'll always get a pi on top and bottom that will cancel because that's kind of like the idea of getting rid of the radians. And then 540 divided by 5 is 108. And I lost a negative along the way, so this was negative, so this needs to be negative. Okay, so now I know that negative 3 pi over 5 radians is equivalent to a negative 108 degrees. Let's just do one more there. So we have 7 pi over 6, so I'm going to do 180 out of pi multiplying, and multiply straight across, so 180 times 7. And I would say sometimes like you could also divide 6 into 180 to start if you can kind of recognize that something is going to simplify so you don't have to rely on the calculator as much. But you can if you want. And so like 1260 is what I get over 6, and then there were pi's on top and bottom. So 1260 divided by 6 is 210. So the pi's will cancel. I'll do that division. I get 210. So I know that 7 pi over 6 radians is equivalent to 210 degrees on the unit circle, on the coordinate plane. Okay. So now there's one last thing we're going to look at today, and that is looking at how we can use radians to calculate the arc length. And the idea of this, it actually relates to geometry still. It relates to the formula for circumference. So I'm going to kind of slide up for a moment and read this kind of formula for arc length. It says, for a circle with radius r and a central angle theta in radians. This is a key piece here. This will only work if you have your angle in radians. The arc length s equals the product of the radius and the angle, which is kind of a surprising statement that your arc length will just be the product, that simple product of whatever the angle is in radians times the radius. But it relates back to your circumference formula, which is 2 pi times the radius, right? So remember, going all the way around the circle is 360 degrees. That's just 2 pi, right, in radians, times the radius to get to the circumference. So now if I'm trying to get an arc length, which is just a chunk of the circumference, instead of having a 2 pi here, I'm going to replace it with whatever angle around the circle I'm going, which will always be like kind of out of the total 2 pi of the circumference. And that kind of gives you that fractional arc length of the total circumference. But for your purposes down here, the only real important thing to understand is that to get a certain arc length measure, you will just do arc length s is equal to the radius times the angle measure. So that's going to be 4 times 2 pi over 3 in this case. So I get 8 pi over 3 as my arc length. And that's it. Okay, we'll do one more. So here, arc length should equal 3 times 7 pi over 6, which is equal to 21 pi over 6. And just kind of always be on the lookout to see can we simplify that answer. But in this case, oh, actually we could simplify because 21 and 6 both are divisible by 3. So then I get 7 pi over 2, which is a little bit of a nicer answer. Okay, so notice I'm never getting decimals here for the pi. I'm always leaving my answer in terms of pi because it kind of creates a nice, neat answer for us. So again, your homework is just the final page in this packet. So you can skip the 3rd page, go right to the back, the page that says homework, and you're doing the entire page. I also do want you to try these last 2 down here. We'll talk about them in class. Have a great evening. It's not the weekend yet, but have a great evening, and I'll see you guys tomorrow.